So today we're going to be looking at solving some word problems and the skills that we've been developing from solving our systems using substitutions or elimination are going to be applied here. So we're going to have to come up with separate equations for the situation. So it's not just going to be one, and then use our skills for solving systems of equations to help us solve the problem. Okay, so let's jump right in. So Cameron's got $450 and he's going to save this many dollars per week. So we already know how to write an equation like that. Let's start with him. So for Cameron, it's $12 per week. So $12 times however many weeks it's been, plus the $450 that he's already got. And then Sean, very similarly, has $290 and he's saving $20 a week. So $20 times the number of weeks he's been saving plus the $290. Okay, now whenever we set these up, in this case, I'm going to use y and x, but no matter which letters you're going to use or what variables you're going to use, you need to define those variables. So y is going to represent the money, how much money he has, either guy. And then x represents the weeks, because you're taking the number of weeks and timesing it by 20 for Sean, timesing it by 12 for Cameron. So y represents how much money each guy has, and x is the weeks. So we've actually already answered letter A. Write a system of equations that represents the situation. And so it's these two equations. So a system just means multiple equations. And it says, after how many weeks will Cameron and Sean have the same amount of money? So when will they be equal? So in this case, you're just going to find out, when is this amount of money the same? When are these y's exactly the same? So that means we can just plug this in, much like we've been doing for y, and see, when does this amount of money equal this amount of money? What number do you put in for x where you get the same number for y? And that's solving a system, getting the pair of x and y's that satisfies both of these. Okay, so what we're going to do is we're going to write 12x plus 450 equals 20x plus 290. So we want to know, when do the weeks equal the weeks? Okay, so we want to find out what is x. And so you've got x's on both sides. You want to go ahead, you want to solve this equation. We're going to go ahead and eliminate the smaller of the two. So I'm going to minus 12x on both sides. We don't have a lot of space here, so we'll make it work. So 450 equals 8x plus 290. Okay, and then at that point, I'm going to minus the 290 on both sides. So this goes away. I'm going to bring it up over here. I'm going to have 8x on the right side. And when I subtract here, I get 160. And so all I'm going to do now is divide by 8. And x equals 20. So the answer here is 20 weeks. So if I plug in 20 for both of them, I should get the same amount of money. And it says, how much money will they have at this time? So I'm going to test both of them out. If I do 12 times 20 plus 450, I'll find out how much Cameron has. And if I use my other equation, 20 times 20 weeks plus 290, I'll find out how much money he has. And this is actually double check us. It should be the same amount. So 12 times 20 is 240. And when you add the 450, that's $690. And then over here, 20 times 20, if he saved $20 over 20 weeks, he saved $400. Plus he had $290 to start. And so he also has $690. And so the answer to the question, after 20 weeks, they have the same amount of money, and that amount is $690. Okay, so that's your pretty basic, straightforward one. Writing equations pretty much in formats that we've seen before. So now let's look at some ones that are different from things we've looked at before. So number 2. Keith purchased 80 jerseys for his football team. Total cost for the jerseys was $38.24. Small jerseys are $38. Large jerseys are $52. Think about what we don't know. We don't know how many small jerseys. We don't know how many large jerseys. We know how much they cost. So if I knew the number of small jerseys, I would times it by 38 to get the cost. And if I knew the number of large jerseys, I'd multiply by 52 to get the cost. And if I added those two together, I would get this total amount of money. Okay, so we're going to start with that as our first equation. We got to write two equations out of this, but that's going to be our first one. So I'm going to use J as one of my variables, and we'll call that the small jerseys. And then we got to represent large jerseys, so I'm going to use L for the large ones. So defining my variables, good habit to get in. So again, the small jerseys, which is J, if I multiply them times 38, so I'm going to write that as 38J, I get the total amount of money for them. And if I add that to the total for the large jerseys, which are 52 each, so 52 times however many large jerseys I've got, that total cost comes out to 38.24. So that's a good equation right there. But I have two variables, and if you have two variables, you can't solve this. So right now, there's no way for me to solve this and find out how many small jerseys or how many large jerseys there are. So I need another equation, and then I'm going to use those skills that we've been practicing, either substitution or elimination, in order to solve this. So this equation represents money. The other information that I have is just the total number of jerseys. So I need to write an equation now that represents that. And so what I know is the total is 80. And what's 80? If I added all of the small jerseys and large jerseys together. Now this has nothing to do with cost, so I'm not going to attach the 38 to the variable. It's just the number of small jerseys plus the number of large jerseys has to equal 80. Okay, so this one just represents the total number. How many smalls, how many large, total of 80. And then this represents the cost. Number of smalls times 38, number of large times 52 equals the total here. Okay, so when you're trying to make two equations for these, think about one in terms of the actual money and the cost, and then one is just the total number of whatever you're talking about, jerseys in this case. Okay, so now we want to know how many of each jersey did he order. So we're going to use this information now to solve. So you got two options. You could go ahead and use elimination if you wanted to. You could multiply this whole bottom equation by something that's going to cancel with these, and that'd be pretty easy to do. If I get this to a negative 38, it'll cancel here. If I get this to a negative 52, it'll cancel here. Okay, and then you just have to make sure you multiply everything. Go ahead and use elimination. I'm actually going to use substitution. And again, either way is going to work. I think substitution's easier here because these are just already so close to being alone that all you got to do is move one, and you've got it by itself. So what I'm going to do is I'm just going to minus L from both sides of this equation. And so my new equation says J equals 80 minus L. And since now I've got J all by itself, this is what J equals. So if I go to the other equation, I can go ahead and just plug this straight in. So 38 times J, so instead of J, I'm going to do 80 minus L plus 52L equals 38.24. So hopefully I didn't lose you yet. I took this equation, I isolated my variable, so now I know what J equals in this equation. And once I know what J equals, I can go ahead and plug it in for J in the other equation. So I've substituted it in. Now all I got to do is solve this. If you take a look, I only have one variable now in this equation. And once you only have one variable, you can solve it. Okay, so we're going to distribute here. This comes out to 3,040. I'm going to distribute here. So I already did this. Distribute here. That's just going to be a minus 38L plus 52L. So the first thing I should do here is combine my like terms. They're on the same side of the equal sign, so we're just going to go ahead and put those together. And that's 14L. I still have this 3040, and you could put it on this side if you want to. It doesn't matter. So all I did in that step was combine these two. Got my 14L. I just brought this down. You could have put it here and put the plus. Doesn't matter. All right, so now I just need to solve this. I'm trying to get L by itself. So I'm going to go ahead and minus my 3040 from both sides. Getting out a lot of space here. I apologize. And bring it up here. So I'm still going to have 14L on the left side. And when I go ahead and subtract here, I get 784. That was from the 3824 minus the 3040. And I'm going to divide by 14. And I get 56. So that means he ordered 56 large jerseys. The question is asking how many of each size did he order. Well, there's 80 total. So if there's 56 large, you could just subtract that from 80, and that'll get you the small. You can show it algebraically. We know that this equation is true. J plus L, small plus large, is 80. So if I go ahead and substitute in 56 for my large, and then just solve the equation, it's the equivalent of what we just talked about. You're showing your work algebraically. So if I take the 56 large away from the 80, that means I have 24 small. You can always go back and double check your work. These add up to 80, so it works for this equation, but this also needs to work for the first one. So if you go ahead and you took J of 24 and times it by 38, and then you took the L, 56, and times it by 52, just real quick in your calculator and add them together, you'll get 3824, and so you know that your answer is correct. If you go back and plug them in and they don't work, then obviously something's wrong. So it's really easy to go back and check your work, especially when you get to a test and you want to just make sure everything's right. Take them and plug them back into both equations and just guarantee yourself that you've got it right. All right, let's try one more now. One that's going to be not quite as explicit. So Stephanie has only dimes and quarters in her purse. Okay, dimes and quarters. We don't know how many. And they're worth a total of this much money. She's got 14 fewer dimes than quarters. So we're going to have to find out a certain number of dimes, a certain number of quarters. And so I'm going to go ahead and use a D and a Q as my two variables. D for dimes, Q for quarters. Oops. I'll come back to the money in a second, but we can go ahead and we can write an equation right here. She has 14 fewer dimes than quarters. So if you know how many quarters there are, there's 14 fewer dimes. So you take the number of quarters, right, and you minus 14 from it. So the quarters minus 14 equals the dimes. 14 fewer dimes. Quarters minus 14 is the number of dimes. So there's my first equation. And now your other equation, we got to have this total of, so it's going to equal $3.85. And so we're going to be talking about the money. So if I knew the number of quarters and I wanted to know how much money they were worth, I would times them by 0.25. And if I knew the number of dimes, I would take that number and times it by 10 cents. And if I add that total amount of money together, it's going to be $3.85. Okay, so obviously I'm good at these. I've done these a million times. So this is not something that you might have thought of right off the top of your head. So examine it and make sure it makes sense, because you're going to have to do lots of equations like this. We know that the total amount of money is $3.85. We don't know how many quarters and dimes there are, but we know how much a quarter is worth. So if I told you there was 4 quarters, you would do 4 times 25 cents. Or if there was 5 dimes, you would do 5 times 10 cents to find out how much money it was. And if I add both of these amounts together, we know it's $3.85. So that's how I built that equation. Now that I'm here, that's my system. I want to know how many of each coin she's got. So now I'm going to go ahead and examine my 2 equations and try and think about what's the best way to do this. So since this one already is written as like isolated, D equals Q minus 4, this is a perfect situation to once again use substitution. D is equal to this whole thing. So that means I can come to the other equation and substitute directly in for D. Q minus 14 goes right in there. So let's go ahead and try and solve this. So I'm going to bring down this equation. And instead of D, I'm going to plug what D is equal to into the equation. And again, what I've done is I've turned this equation into something with only one variable, which means I can solve it. So we're going to go ahead and simplify. It looks complicated because we've got these decimals, but it's not too bad. So I'm going to distribute the decimal times Q. And I'm going to distribute it here times the 14. And that's 1.4. And now I just have to solve this. So first of all, these are on the same side of the equal signs, my Q and my Q. That means I can combine them. So that's 0.35 Q. And now I'm just trying to get Q by itself, so I'm going to add 1.4. I still have 0.35 Q on this side. Add those together, comes out to $5.25. And I'm just going to divide that now by the 0.35. And you run that through your calculator and you find out that Q equals 15. So that means the number of quarters is 15. Remember, the number of dimes says she has 14 fewer dimes than quarters. So if she's got 15, 14 fewer than that would be 1. If you want to show it algebraically, go ahead. Q minus 14 equals D. Use that equation, plug it in. So 15 goes in for Q. And that means she's got 1 dime. So 15 quarters. 1 dime is our answer. And again, you can go back and double check it. If there's 15 quarters, do 25 cents times 15. And if you try that, you get $3.75. And then if you think about it, that means I'm only 10 cents short here while I have 1 dime. And so that gets me to that amount. So I've got the perfect 2 numbers that satisfies both equations here. So these are going to take a little bit of practice in terms of building it. I know we've now got the skills to solve them, but now when you have to actually build those equations yourself, it can be a little tricky. Okay, so today we're going to get started with that, and we'll just keep practicing and taking a look at some different kinds along the way just to strengthen our skills.